Hi everyone. Today we're going to continue with comparing two means, looking at paired data. This is our second day on this topic. And last time we weren't able to quite make the full confidence interval. So we are going to look at that and we'll go through the whole SPDC process for a confidence interval for a mean difference. So right at the end of our last lesson, we talked about the conditions, which you'll notice are not any different from anything we've learned so far. Same three over and over. Random, 10%, and our normal/large sample. All right, so now let's look at the actual structure of the confidence interval. So for this particular chapter with paired data, you are actually using a one sample t interval. So although you are essentially getting two different lists of data initially, when you find the differences of those of two data points, you're going to end up with one single sample. So we actually construct the interval just like we did for a one sample t interval for a mean, for a population mean, but this is for a mean difference. And it's also called a paired t-interval for a mean difference. So notice it starts off with the sample mean difference here, plus or minus t star times the standard deviation of the differences, that's sample standard deviation, divided by radical n of your differences. So if you have just 12 pairs of data, you would have a radical 12 down here. All right, and that t star is your critical value, and we follow n minus 1 like we did initially back in chapter 9. So there is no complex degrees of freedom formula for this section because we're treating it like a one sample t interval. So let's go back and return to this problem that we initially talked about yesterday, where we had 12 pairs of twins separated at birth, raised in different households. One twin going to a high-income family, one going to a low-income family, and then figuring out, what the mean difference is between those two twins. So we're going to construct a 95% confidence interval for the true mean difference in IQ scores among twins raised in these two separate types of households. So let's go through the whole process of the SPDC. Starts off with our state. We want a 95% CI for mu diff, where mu diff, meaning mu difference, is the true mean difference, high income minus low income, in IQ scores for pairs of identical twins raised in separate households. Very important here that you state the order of your difference. So notice all of our differences down here are A minus B. They are high income minus low income. If you define your difference as low income minus high income, you'll get a different interval, and that's totally fine if you define it at the beginning. So we've made a very clear declaration that we're going A minus B, and that's what our difference is. So very important you state that correctly. Now for our plan, this is a one sample t interval for mu diff, or you can call it a paired t interval if you'd like. It's random because we have a random sample of 12 pairs of identical twins, one raised in a high income household and the other in a low income household. 12 is less than 10 pairs of all identical twins raised in separate households. Okay, so we're going to go ahead and assume that. Now our plan portion, we are not at 30, so we must graph we must provide some kind of a sample graph of the data here. And that's what this dot plot indicates, and we talked about this in our last lesson. So you're looking out for any strong skewness or outliers. Not much going on here. Looks relatively safe to proceed. There's no data values that are extremely further away from the others, nor is there any strong skewness. So we are now ready for the do step. So for our do step, I believe we calculated this last time. We made a list of this data right here in our calculators. And we used one variable stats on our calculator to find out the difference. You could, of course, also add those 12 values and divide by 12. But remember, the standard deviation is a very tedious calculation if you're doing it by hand. So our calculator will provide those two values, and we have 12 differences. So if you are doing this by hand, there's 11 degrees of freedom, and that gives us a t-star of 2.201. So gives us a t-star of 2.201. Now again, where does that come from? We're going to go to table B, which is the table of t-distribution critical values. So remember, at 11 degrees of freedom, which is right here, we're looking for the 95% confidence interval, which is this column right over here, which corresponds to a tail probability of 0.025. So 11 degrees of freedom, 95% confidence is right here, 2.201. And it's not different at all from what we did in Chapter 9 with the one sample t-interval for a population mean. So now we have our point estimate, our 5.833, plus or minus our critical value, times our sample standard deviation, divided by radical n. We get our point estimate, plus or minus our margin of error. Add the values up, subtract them, and we get a interval that tells us that the true mean difference is between 3.336 and 8.330. So it tends to side with twin A. Twin A minus twin B, on average, will have this difference, with that 95% confidence that we have. So now you can do this on your calculator. Okay, and it does require, you probably would have had to make a list anyway if you were calculating the mean and standard deviation. Probably have the list in your calculator to do it by hand the way on the previous slide. So if you're doing it this way, you go to tests and you're going to use the t-interval test. Don't use a two-sample t-interval because we are treating these two sets of data as pairs, which is essentially the same as one single set of data. So it's a t-interval. We're going to input data from L1 at a frequency of 1 and a C level of whatever is given. And here it's 0.95. And when we calculate that, notice the interval is all but identical, probably differs by a few decimal points. Okay, so make sure if you use the calculator, you say something along the lines of, this is I'm using the t-interval on my TI calculator, and make sure not just to write the answer for the do step. All right, so conclusion time. We are 95% confident that the interval from 3.336 to 8.330 captures the true mean difference. Again, very important what direction it is, high minus low, in IQ scores among pairs of identical twins raised in separate households. So that's our conclusion. And let's go ahead and try one more problem. All right, so for this very last problem here, it says that Mrs. Gallus hoped to determine if the two versions of her AP Stats final exam were equally difficult. Last year, she set up a randomized comparative experiment, and the data showed no statistically significant difference in the scores between the two versions. This year, she selected a random sample of 20 students from the large district and used a matched pairs design where each student was given both versions of the test. For each student, the test order was randomized. Here are the scores along with the differences in scores for each student. All right, so as you can see, we have version A. These are all identifiers. There's 20 students. Names are not given to protect privacy, right? So we have version 1, or student 1 took version A, got 90, got an 86 on the second version. The difference in those scores is 4. Let's go on student 3. Student 3 scored a 77 on version A, but did a little better on version B. So A minus B would give us a negative value. Now, quickly scanning through the bottom row, notice that there are not too many negatives. So if we wanted to know which might be the more difficult version just by quick glance, it looks like version B might be a little more difficult because we just don't have as many positives. We don't have as many negatives, which indicate that students scored better on version B. All right, but we're going to construct an interval and hopefully get to the bottom of this. So we are going to construct a 99% confidence interval for the true mean difference of version A minus version B in final exam scores for AP Stat students in this district. All right, so I am going to pause, or actually I want you to pause the video and make a list of the data on the very, very last row. Okay, we're going to make an L1 out of all of these data values. Make sure, I should have mentioned this earlier, make sure that you don't put -3, put -3. If you put the minus sign, you're probably going to get a calculator error. So make sure this is a negative and not a minus. And make a list of all those differences, and then check back when you are ready. All right, so let's start off with the state portion. 99% CI for mu diff, the true mean difference, version A minus version B, in final exam scores for AP Stat students in this district. We are going to conduct a one sample t-interval for mu diff, or what we can also call a paired t-interval. The random condition, we have a random sample of 20 AP Stat students in the district. She also did randomize the order of the test, so that's another consideration. Now, we are checking 10% because she did randomly pick these 20 students from the district. So although this is an experiment, she did randomly select from a population. So that's going to require us to check the 10% condition. This is one of those rare situations where we randomly select people and choose them to take part in an experiment. Very, very rare, but this is probably a hypothetical example from our textbook, so we're going to go with it. 20 is less than 10% of all AP Stat students in this large district. So because we're only sampling 20 students, we are going to have to check our dot plot of our sample data. Nothing drastic here, no outliers, no skew, roughly symmetric, nothing major here. So we're going to go ahead and proceed. All right, so if you want to use a table B, you would go 19 degrees of freedom at 99% confidence. So if you look that up, you should get 2.861. And here is the interval done completely by hand. Notice that both numbers are positive, so the true mean difference is 0 is not included in that true mean difference. So that kind of tells you that it looks like test A was a little bit easier, or that test B was a little bit harder because A has a higher mean score. Okay, so our conclusion, we are 99% confident that the interval from 0.94 to 5.46 captures the true mean difference, version A minus version B, in final exam scores for AP students in this district. And I also forgot to mention, this is how you would do it with your calculator, assuming that you have an L1 that was made of those 20 differences in the test scores. All right, that's going to do it for today. Tomorrow we will talk about hypothesis tests, and then we have a Chapter 10 test coming up real soon. Have a great day, everyone. Take care.